Burning fossil fuels is heating the planet, but does that mean that stopping burning fossil fuels would stop heating the planet? Or would the world continue to heat up for centuries to come, even after we stopped greenhouse gas levels going up? And how could the answer possibly be yes to both these questions at the same time? I'm Adam, a climate scientist with a PhD from Oxford, sharing what you need to know about climate change. And today I want to talk about what happens when we stop emitting carbon dioxide. Well, the world stops heating up. End of story. But what about committed warming for the carbon dioxide we've already emitted? What about aerosols? Yeah, and what about methane? Okay, fine. I guess it's not quite the end of the story. So you said that zero CO2 emissions means zero warming. Why? Ultimately, it's because there are two forces balancing each other out. So, by emitting carbon dioxide, we're gradually turning up the dial on how much CO2 there is in the atmosphere. The more we turn the dial, the hotter the world, or the oven, gets. And side note, but I am very proud of my induction stove, so take that, weird culture war. Okay, but now if we stopped raising CO2 levels and instead kept the dial fixed at one position, well then the world would still be playing catch up. It would take a while for the oven's temperature to reach equilibrium with the dial. And that's exactly what would happen with our planet. You see, oceans and ice take a long time to catch up with what's been happening in the atmosphere, a bit like a cool swimming pool takes a long time to heat up on a hot sunny day. And as the oceans and ice gradually balance out with the atmosphere, temperatures would keep rising for years, decades, and potentially even centuries. Exactly! I've heard loads saying that the world would continue to heat up, like this study from James Hansen. You mean the former director of the NASA Goddard Institute for Space Studies and the scientist who sounded the climate alarm to US Congress? Yes, him. So Hansen's study argues that the world could heat by a total of 10 degrees Celsius with today's greenhouse gas levels. But if we stopped emitting greenhouse gases, they wouldn't stay at today's levels. So if we stop turning it, the CO2 dial would gradually rewind. In other words, once we stop emitting it, concentrations of carbon dioxide in the atmosphere would gradually decrease as CO2 gets taken up by oceans and land. And this would effectively cancel out that gradual heating that we mentioned a few seconds ago. And so if we stopped emitting CO2, our best estimate is that the heating would also stop. Studies that suggest that temperatures would keep rising are generally looking at what would happen if carbon dioxide levels stayed fixed in the atmosphere. In other words, if we fixed the dial at one position. And that's a perfectly legit thing to look at, but it's a different thing to look at than what would happen if we actually stopped emitting. The Hansen study in particular, which got a lot of attention despite not yet having been peer-reviewed or published, is about what would happen if all greenhouse gas levels stayed fixed in the atmosphere. More on other greenhouse gases in a moment. If you don't believe me that the James Hansen study isn't about some kind of unavoidable committed warming, maybe you'll believe James Hansen, who said, "The word committed, or commit, does not appear in our paper. If it had, it would have been in a statement such as, the world needs to commit to global cooling of about 1 degree Celsius for the sake of young people and future generations." I was going to try and do a James Hansen accent, but I chickened out at the last moment. So why do I keep hearing that we're trapped with more warming? Honestly, some climate scientists and climate communicators confuse this issue all the time. So I definitely don't blame other people for being confused. But yeah, stopping emitting CO2 stops warming. But how do we stop emitting CO2? Well, we can think about the flow of CO2 emissions like water filling up a glass that's about to overflow. The priority has to be turning off the tap as much as possible, as quickly as possible, which means transitioning away from fossil fuels as much as possible, as quickly as possible, and to things like renewables and nuclear power. But there are some things we don't know how to decarbonize. yet, and so we can't turn the tap off all the way. And so we have to find some way to suck up a bit of CO2 to balance out the flow. This means doing things like planting trees and using new technologies. This balancing out is what the net refers to in net zero. If you want to know more about how we turn the tap off as much as possible and how we suck up that last little bit of CO2, well, I'm planning a video about exactly that, so make sure you subscribe so you don't miss it. And while you're clicking on things, you might as well do that whole like and comment thing. But CO2 isn't the only thing we're emitting. What about aerosols? I heard they're hiding some warming. They are, and this effect is called aerosol masking. Aerosols are small particles or droplets in the air which come from a whole host of polluting processes, both natural and human caused. But they're not just the things you get from spray cans. Overall, they cool the planet down by reflecting away sunlight. But they fill up in the atmosphere like water filling up a plant pot. And so if we stopped emitting them, they'd disappear from the atmosphere pretty quickly. So if they cool the planet when they're in the atmosphere, but they'd disappear from the atmosphere when we stopped emitting them, then we would see a sudden bump in global temperatures. Well, that seems pretty worrying. Well, it's worth taking into account two things. The first is that this aerosol cooling effect is absolutely taken into account by climate scientists when they work out things like limits for how much fossil fuels we can still burn. It isn't like some hidden extra factor. The second is that there's another important factor too. Other greenhouse gases besides carbon dioxide. And before we get to those, a quick note about my sponsor, which is that I don't have a sponsor. I don't want my videos to sell you things with ads and sponsorships, and so I don't do things like ads and sponsorships. Videos like this one are entirely supported by incredible patrons like Frank. If you want to be incredible like Frank, well then click over here. Okay, now you've finished asking people for money. Can you explain the other greenhouse gases? So gases like methane are a bit like carbon dioxide in that they're also greenhouse gases that we've been emitting loads of, heating up the planet. But they're also a little like aerosols in that they don't last too long in the atmosphere once we stop emitting them. Oh my god, this is such a balancing act. Yeah, what would happen if we stopped emitting everything? Carbon dioxide, methane, aerosols, everything. Well then temperatures would stabilize pretty quickly at roughly the temperature that we had when we stopped emitting. So if we stopped emitting today, then no more warming. Well, I hate it when you say well like that. Well, we would see no more global warming, but we would still see, unfortunately, more changes to the climate. So for example, glaciers would continue to melt, affecting all the people who rely on them for fresh water. And speaking of ice melting, sea levels would continue to rise for centuries, affecting the many millions of people who live in coastlines around the world. And ecosystems would continue to shift in response to the heating that we've already caused today. Okay, but this is all very theoretical. We're not about to stop emitting everything today anyway, so why are we talking about it? Well, because it's in the title of this video. Yeah, but what would actually be a more realistic scenario? Well, what's more realistic is a gradual transition away from fossil fuels, which would mean a gradual phase down of emissions. And exactly what would happen would depend on exactly how we phase down those emissions. But a good rule of thumb is that temperatures would still stabilize once we stopped emitting carbon dioxide. And while we're being more realistic, it's important to point out that there are ranges for all these answers. We don't know exactly how all the different processes balance out. So, for example, if we stopped emitting carbon dioxide when the world had already heated by 2 degrees Celsius, well then the temperature could end up stabilizing at anywhere between 1.7 and 2.3 degrees Celsius. On top of that, there could be some feedbacks, like frozen lands thawing and releasing a whole bunch of methane, which would heat the planet up an extra chunk. But what we know for sure is this: the sooner we stop emitting, the lower the initial temperature rise would be, and the lower the risk of feedbacks like this. Okay, but if we're being realistic, is net zero really a legit concept? Well, the term definitely is used and abused by everyone from petrostates to oil companies. And so here's how to make net zero actually make sense. Okay, until next time. Bye.